So our next part of chapter 2 is on standard scores. So this is 2H. So it is common to transform data into a new set of units that show the number of standard deviations a data value lies from the mean of the distribution. So you remember from last lesson when we're talking about the normal distribution, how far away from the mean one standard deviation from the mean looks like, what it looked like, and that was your 68th percentile, etc. So this is what we're talking about. This is also called standardizing, and these transformed data values are called your standardized or your Z score. So I'll usually just call it the Z score. Okay, so you've got to work out what the Z score is based on some information. So the Z score or standard score, that's your Z score. Your Z score is equal to your data value, so your actual data value minus the average divided by the standard deviation. So in notation, we use Z equals X for your actual minus the average divided by SX, which is your standard deviation that they give you. So make sure you have this formula with you in order to answer the questions. But what does it mean? A positive Z score indicates the actual score it represent lies above the average. If it's a 0, it is equal to the mean, it is on the average. And if it's a negative score, it indicates that the actual score lies below the average, below the mean. So that's what it is. And now let's take a look at some examples. So let's have a look at this question here. The heights of a group of young women have a mean of 160 centimeters, a standard deviation of 8 centimeters. Determine the Z score, so this is what they want us to find, given that the woman is 172 centimeters tall. So for A, the actual height is 172 centimeters score, and they want us to work out the Z score. So in this situation, Z equals actual minus the average divided by the standard deviation. It's just a matter of substitution here. So we know that the actual is 172 minus the average, which was 160, divided by 8 for that one, and we get a Z score of 1.5. So that's how you work it out for that one. And it's also giving you the example just over here. Now the next one, same sort of thing, 150. So instead of doing 172 there, you would plug in 150 minus 160 divided by 8. And B gives you an answer of negative 1.125, which is there, the Z score. And the last one, 160 centimeters, I already know it's going to be 0 because it's that. And you get 0 Z score for that one there. So that's how to work out the Z score. Using standard scores to compare performance. So this is like, when you get a couple of subjects, which one did you do better in based on the average and based on the standard deviation. Again, the way to do this is to use your Z scores. So let's have a look. Standard scores are also useful for comparing groups that have different means and or standard deviations. So for example, consider a student who obtained a mark of 75 in psychology and 70 in statistics. So I'm comparing psychology with statistics. So psychology, did I spell that right? Psychology versus stats. So I want to see which one did better. So this is in which subject did they do better. So this is where it is here. And the best way to obtain that is using your Z scores. So you've got to work out the Z scores for both. So let's look at psychology. Standardized mark for psychology would be the actual score, which was 75, minus the average divided by the standard deviation. Statistics, same thing. Actual minus average divided by standard deviation. Z score for psychology is 1, and the Z score for statistics is 2. 1 and 2. These are the important. What do we see? The student obtained a higher score for psychology than for statistics. However, relative to her classmate, she did better in statistics because the Z score is higher. Her mark of 70 in statistics is equivalent to a Z score of 2. This means that her mark was 2 standard deviations above the mean, placing her in the top 2.5% of students. Her mark for 75 for psychology is a Z-score of 1. So she was in the she was 1 standard deviation above the mean, placing her in the top 16% of students. So this is a good performance, but not as good as statistics. So that's all it is. It's not that hard. Another one. Another student studying the same 2 subjects obtained a mark of 55 for both psychology and statistics. Does this mean that she performed equally well in both subjects? Use standard marks to help you arrive at your conclusions. So in this situation here, she got 55 there, 65 was the average there. You work out the Z-score, it was -1. Statistics, the Z-score was -1. So that means her standardized score is -1 for both. So yes, it was the same for both subjects. In both subjects, she finished in the bottom 16%. Why in the bottom 16%? 1 standard deviation below the mean. The mean is here. 1 standard deviation below the mean means that 68% of people were in this range. Remember that normal curve? 16% in here. She was here, 1 below, meaning bottom 16%. And that's all it is. It's very, very simple. Converting standard scores into actual scores. So this is just all about transposing your equation. You guys can actually do this on your calculator using the solve function. So, for example, if you've got Z-score equals X minus the average divided by standard deviation, they want you to work out this one here, given all of this information. So you can use your solver, or you can use this formula over here, that your actual score equals the mean plus your Z-score times the standard deviation. So you can use either. It's quite easy. It's substitution, or use the solve function on your calculator to get that. So in this question here, a class test out of 50 has a mean mark of 34. The standard deviation is 4. Joe's test mark was that, Z-score was that. What was his actual mark? You can work it out by putting it into this or using solve. And it's just a matter of substitution or using your graphics calculator. And when you do that, you'll get that he got 28 out of 50 for that type of question. So you can continue on with those questions and have a go at 2H.